Hello everyone, a warm welcome to you all. Myself I am Lakshmi Prasanna Bellamkunda. I am from ECE A section and my roll number is 20bq1a0416. I am from Vasireddy Venkatadri Institute of Technology. Today I am here to explain a few words about green chemistry and its 12 basic principles. So let's go on to the video. Before going to the 12 basic principles of green chemistry, let us see what is meant by chemistry and its history. Green chemistry. It is the utilization of set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture and application of chemical products. And the father of green chemistry is Paul T. Anastas. Green chemistry becomes insignificant as it paves the way for clean and sustainable growth. Green chemistry is based on 12 basic principles known as principles of green chemistry. Let us see what are the 12 basic principles of this green chemistry. First one, pollution prevention, and second one is atom economy, third one is less hazardous chemical synthesis, fourth one is designing safer chemicals, fifth one is safer solvents and auxiliaries, sixth one is design for energy efficiency, and the seventh one is use of renewable feedstocks, eighth one is reduce derivatives, and ninth one is catalysis, 10th one is design for degradation, and 11th one is real time analysis for pollution prevention, 12th one is inherently safer chemistry for accident prevention. Let us see one by one very briefly. And the first one, pollution prevention. As we have a slogan that prevention is better than cure, it is very much necessary to prevent than curing. It is better to prevent waste than to treat or clean up waste after it is formed. An ounce of prevention is worth a pound of cure. A chemist in a green chemistry lab is performing pollution prevention on molecular level. The only brief explanation of this topic is after the waste is forming, cleaning up, we should prevent the waste before it is forming. And the second one is atom economy. Synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product. Waste not, want not. A chemical reaction A plus B is lies to C. Cooking analogy. Ingredients in, product out. Where do products come from? See, here we can see atoms are turned as molecules and molecules to materials and materials to will obtain the products. And this atom economy mostly focuses on how the atoms to molecules. And when coming to examples of atom economy, here we can see the example as Diels-Alder reaction 4+2 cycloaddition. Here the reactants we are using are 1,3 butadiene ethylene and we obtain the product cyclohexene. And the second one, catalytic reduction. Here we are using prop 1 ion and as catalysis palladium barium sulfate and catalytic reduction, and we obtain the product prop 1 ene. And the third one is less hazardous chemical synthesis. Whenever practicable, synthetic methodologies should be designed to use and generate substances that possess little or no toxicity to human health and the environment. When chemists do chemistry, they have a choice in how they do it. Choosing the faster method in chemistry is like using a screwdriver instead of a knife to tighten a screw. The knife might be able to tighten the screw, but it's dangerous. And less hazard. We have to prepare some chemical. We have a traditional way and a green way. Well, let's see a traditional pathway. In this pathway, we have some hazardous method. Traditional or conventional method for synthesis of adipic acid uses carcinogenic benzene as starting material. Here in this traditional path to synthesis of adipic acid, we are using carcinogenic benzene as a starting material, which is very hazardous. But in green path, we are using the most commonly used green procedure for synthesis of adipic acid uses cyclohexene as the starting material, which is very safe to our environment. And when coming to the fourth one, designing safer chemicals. Chemical products should be designed to preserve efficiency of the function while reducing toxicity. Chemists are molecular designers. They design new molecules and new materials. Green chemists make sure that the things that we make not only do what they are supposed to do, but they do it safely. This means that it's not only important how chemists make something, it is also important that what they make is not harmful. Making safe and non-toxic products is the goal. The brief idea of this is not only making the chemist is not only making a product, but it also should be safe to the environment. It should not be hazardous to the environment. And the fifth one is safer solvents and auxiliaries. The use of auxiliary substances, solvents, separation agents, etc. should be made unnecessary whenever possible and when used unconscious. Many solvents are hazardous and non-toxic. They are safer alternatives. Green solvents, water, supercritical water and supercritical CO2, ionic liquids. And the sixth one, design for energy efficiency. Energy requirements should be recognized for their environmental and economic impacts and should be minimized. Synthetic methods should be conducted at ambient temperatures and pressures. Chemists also use lot of energy, heating, drying, cooling. Energy is not only expensive, most of the time the power plant that creates the energy contributes to pollution. And the seventh one is use of renewable feedstocks. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practical. Green chemists look for alternative sources for making material. Renewable feedstock, corn, potatoes, biomass can be used to make many products, fuels, plastics and more. And the eighth one is reduce derivative. Unnecessary derivatization, blocking group and protection, deep protection, temporary modification and physical and chemical processes should be avoided whenever possible. And the ninth one is catalysis. Catalytic reagents as selective as possible are superior to stoichiometric reagents. In chemistry and biology, catalysis is the acceleration of a chemical reaction by means of a substance called catalyst, which is itself not consumed by the overall reaction. Reduces energy, increases efficiency, reduces byproduct formation. And the 10th one is design for degradation. Chemical products should be designed so that at the end of their function they do not persist in the environment and instead break down into the unconscious degradation product. It means if a chemical product is made, it should be degraded into the environment. It should not make the harm to the environment. And the 11th one is real-time analysis for pollution prevention. Analytical methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substance. Real-time analysis for a chemistry is the process of checking the progress of chemical reaction as it happens. Knowing when your product is done, you can save a lot of waste and time and energy. And the 12th and the last one is inherently safer chemistry for accident prevention. Substances and the form of substance used in a chemical process should be chosen so as to minimize the potential for chemical accidents including releases, explosions and fires. Tragedy in Bhopal, India, 1984. In arguably the worst industrial accident in history, 40 tons of methyl isocyanate were accidentally released when a holding tank overheated at a Union Carbide pesticide plant located in the heart of the city of Bhopal. 15,000 people died and hundreds of thousands more were injured. As we know, in our history, we faced a tragedy, that is Bhopal tragedy, where 15,000 people are died and hundreds and thousands of people were injured due to methyl isocyanate was released in the industry, which is at a heart of the city. Chemists try to avoid things that explode, light on fire, or air sensitive, etc. In the real world, when these things happen, lives are cost. When these Bhopal tragedies happen in our real world, our lives are very dangerous. So these are the 12 principles of the green chemistry. Hope you understand the topic of these 12 principles of green chemistry, and thank you for listening my presentation. Thanks a lot.